Okay, in this video for Grasshopper tutorial, I'm gonna create a continuous curve that wraps this torus shape around continuously. So let's just do that. And in this Wikipedia about torus, it has the formula of the torus using the trigonometry, so I could just use this in Grasshopper to create the torus shape in point based. Okay, so let's start by creating these using this formula to actually create a point collection for which makes up the torus first. So I'm gonna make a construct point, and you can input x, y, and z, and this one tells you the x, y, and z value, the formula. So the R, the big R, the capital R should correspond to the overall radius of the torus. So let's make a parameter for that, something like 100. And then the small r, the lowercase r, stands for the radius on the section circle. So let's make it a bit smaller, like 65 or something. And then for this theta, I think it corresponds to the angle of the points around the section circle. So let's make that. I'm gonna use range, and well, since I'm making a whole round one continuous circle, it will be 2 pi, which means 360 degrees. And let's define the number of point for the section circle. Let's say 10 or 20. And now let's say this is the theta. I'll make a cosine out of this for the first x and y, and multiply this with the small lowercase r. Okay, that's for the both x and y. And after that, I need one more angle here. Okay, so let's make that as well. That one's for the angle for the circle, which lies on the xy plane. So I'll just copy this and make it a different number here to make it easy to understand. And for this value, I'm gonna make a cosine, this new angle, and multiply this capital R plus lowercase r times cosine, which is this one, with the cosine new angle. And I also have to make the sine version here, and also do the multiplication here. Okay, so this should goes to x, this should goes to y, I think. Let me check. Oh yeah, and I in order, well, since this one, the one I made it here, which is a list of the points on the section circle, and this one's on the plane circle, xy plane circle, you have to graft it to make a cross reference. Right, it start looking like a torus, and then I need the z value to actually make it as a torus. So this one, lowercase r, which is this one. Oh, wait a minute, I forgot to add this capital R for this one, so I have to do the addition with this. Okay, and put it here. Right, and for the z value, I'll do a multiplication, lowercase r. Let's just name it here R, capital R, and make this group. Okay, and a r times, lowercase r times sine of this value, which is a theta. Place it here. Okay, and let's connect it to the C input. Alright, now it seems like I have made a point list which construct the torus. If I increase the division, the range of this numbers, which will increase the section numbers. If I change here, it will change the number of points for the section curve, section circle. Now what I want is to have a single continuous curve that wraps all these points to actually make a continuous curve which will make a torus. And let me first try connecting all those points together at this point to see how it looks like. And if I connect polyline here, now it's connecting on the section side, so I'm just gonna flip it. And if I connect the polyline, well, it's making a circular curve for each section points. But as you can see, it's not continuous. It's all the curves, all the circle curves are separated together, so I just want to make it continuous. So how should I do that? Now think about that this angle, this theta angle, is an angle for each section circle, corresponds to each section circle. So if you look at it, so it's from 0 to 2 pi and divided in 24 range. Now, so what I just simply want to do is that for each circle, lift up the points a little bit upwards or downwards to somehow, when it goes around 360 degrees, it somehow connects to the start point of the next circle curve. And the range of the angle, how much I should move from here to the next curve is this first angle information that you can get from the range. So I'm just gonna delete the group. I'll get the second item from the range, which is this angle, which is the angle which corresponds to how far these curves are separated. And I'm gonna make a new range using this value, and also thinking that how many points I should move like upwards for each circle is the same number as the number of the value that resulted from this range. Because if you see at one circle, you have exactly 12 points using this value, which corresponds to the angle of each point on XY plane. So I'll simply use 11 at this in this case for the division n, and what I get is this value 0 to 0.26 divided range in 11 divisions. And what I need to do simply is to modify the angle that I'm using for cosine and sine at here by, I'm gonna graph this first and then add this value to this one and connect it here and connect it here. And if you see it, now it's connecting continuously. And that's it. That's totally it. And if you increase the value, even if you increase the value or decrease the value, it still connects like this. Alright, so let's call the first index for this one and then flatten this and connect the curve using nerves curve with the closed option on, and voila, that's totally it. I'll make a pipe as a final touching, make a parameter for the radius. Right. Let's color this. Maybe I could change it as a mesh and make an interesting coloring. Oh, it's okay. I'll make it blue here. And this itself, you can control the auto radius, the radius for the section, a number of sections, number of, how should I say? Well, section points and the number of the XY plane radius. This one doesn't really make any changes since it's a nerve, so just changes the resolution. So maybe 15 or 10 is fine. Yeah. And let's add one more variable so that I can somehow animate the movement of this continuous curve, like upward or downward. Now, in order to do that, let's make this go a little bit to the right. And what I need to do simply, I think I just need to add some angle to this value and connect to the cosine and sine, which will make a animation, I believe. So let's make a timer. Turn it off for now. And the counter. And connect it here. Make a boolean. For now, let's make it true. And for t, multiply this with some angle. Let's say like 10 degrees. Convert it to radians. And add it to this value. Okay. And let's change this to 50 millisecond, connect the false. And yeah, it's somehow moving. Maybe I should make it a small degrees or 2. Well, seems a bit heavy, so I'll reduce this to 10 or 15. Nope. 13. Oh, 15. Okay, I found something weird inside. I think I have to fix that thing. Okay, let's stop this. Okay, well, this connection is a bit strange. Yeah. And I guess it's coming from this connection. If I make it false. Okay. What if I... Okay, let's flatten this thing and do a remove duplicate points from the kangaroo component and connect this here. Okay, well, this seems to work okay. Alright. And let's make this 15 and I want to see this from inside, so okay, let's go to the camera settings and change the lens length to 20 or something. And I want to go inside. Okay. Let's hide the grid. And make it high quality. And let's try animation again. Yeah. Yeah, I guess it's interesting. Okay, that's it. Thank you.